Good afternoon, distinguished ladies and gentlemen. So today I want us to look at MSM 192 Tutorial Sheet 1 2025-2026 intake. So for this tutorial sheet, it is and based on simple interest. So, or rather, let me just say interest. So, the first part now, the first set of questions are on AP and GP. So, first let's look at the first set of questions, which is under AP and GP. So, let's go to the question. So, the question one is saying, derive the sum of an arithmetic progression when the nth term is known. So, in the previous session we had, I taught you on how to go about with this question. So, but for the sake of my brother and my sister, so I'll go back. I'll do this question once again. I even told that these questions are very common. So they are mostly there in tutorial sheets and probably in quiz one and test one. So let's derive out the sum of an AP. So it's saying as if the nth term is known. So the nth term is the last term. So suppose the last term of an AP, you are given, say, this one is the last term of an AP. Which formula do you have to use? So let's derive out this formula. So you are on question one. So we know that for an AP, the sum of an AP so is equal to. So the first term of an AP is given by A plus. The second term is given by A plus the common difference. So the common difference is the difference between the first term and the second term. So for the second term, I'm going to add the common difference with the first term to get the second term. Then plus, we're going to add the common difference with this with our second term to get our first term. So we have A plus D, A plus D plus D. We're going to have 2D. So we're going to have A plus 2D. So this one is our second term. Then plus. So this carries on over and over and over again plus. Then let's look at the last two terms. So for the last two terms of an AP, you're going to have, so the last term of an AP is given by AN. So this is the last term of an AP. So to find the second from last, you're going to have AN minus what? Minus the difference to find the second from last. Then plus. The last term of an AP is given by what? A. And so this is the last term. So this is the sum of an AP. So if you add this, you're going to have the sum of an AP. Then we can also write this formula starting from from the last term to the first term. So let's write this. So of S of n is equal to. So what is our last term here? Our last term is given by A n then plus. What is our second term? Second from last we have A n minus D, which is last term minus difference to get the second from last. Then plus. This one carries on. Then plus. Let's look at the second from last. So the second from last term is A plus D. So we have A plus D. Then plus the first term, which is A. So this one is the second from the first, the second is the second term, then this one is the first term. So now when adding, you can add from the first term and the last term, the second and the second from last. Yeah, so let's add the first equation and the second equation. So S of 1 plus S of 1, I'm going to have 2Sn, which is equal to, what is A plus An? So we have A plus An, so which is going to give us A plus An, then plus, we go to the second term and the second from last. So we have A plus An, then plus D minus D. So D and D, this one is positive, this one is negative. So as simple as that. So these two, they are cancelling out each other. So we're going to remain with A plus An, which is A plus An, then plus. So we do the same for the second term and the first term and the third from the last. It's going to give us the same answer. Then let's look at again. Let's go to the last part. So we have the second from last term plus the second term. So we have D and D. This one is negative, this one is positive. So these are cancelling out. So we're going to remain with A plus An, which is plus A plus An. So A plus An, then plus, we go to the last term and the first term. So we have A and A. The first term is A, the last term is A, and so we have plus A plus An. Then let's look back at this question. So we have 2Sn is equal to a plus n. So a plus n, they are just repeating each other. So what we're going to do is we're just going to get a2sn is equal to. So among these, you're going to just get a plus an because they are repeating each other. So these are repeating each other, so it means they are a lot. So since we don't know the exact number they are, so we're just going to represent them by the letter n, which means their total number is unknown. So we're going to represent them n because there are n of them. So if you divide by 2, even when you divide by 2, you're going to remain with Sn is equal to n over 2 multiplied by a plus a n. So this is the formula for an nth term, for sum of an AP if the nth term is known. So this one is number of terms. This is the first term plus the last term. So you just add the first term plus the last term, then you divide by the number of term by 2, then you multiply them together to find the sum of an AP. Now let's move to our question 2. So our question 2 is saying show that the sum of the first n terms of an AP. So the first n terms of an AP with the first term a. So we have first term was a, and what? And the common difference, common difference, which is d. So you have a, d, and n terms. So show that the formula is equal to what? Sn is equal to n over 2. Then you have 2a plus n minus 1 d. So you have to show that if we solve for the first 10 terms of an AP, where we have the first term as a and the common difference d, that the formula is this one. So let's derive out this formula. So this is our question 2. So we know that for sum of an AP is equal to, so what's our first term? The first term is a plus. What is the second term? The second term is a plus d, then plus the first term is a plus 2d, then plus it carries on, then plus the second from last will be given by, so for an AP, the last term of an AP will be given by the nth term of an AP. We know that the nth term of an AP is given by what? An is equal to a plus n minus 1 d. So using this formula, we can use it to this. So this one should be for the last term. Then for the second from last, you're going to have a plus n minus 2. So this n, you're going to subtract it by 2. The nth term, I'm going to subtract it by 2 to find the what? The second from last. Then plus the last term will be a plus n minus 1 d. Then we can also deduct it from the last term to the first term. So we say Sn is equal to, what is our last term? So our last term is a plus n minus 1 d, plus the second term is a plus n minus 2 d, then plus we go now from the we go to the first part now. So the first part, you have the first term, second term, and the third term. So we're going to subtract it by, we add go to the second term, so which is plus a plus 2d, which is the third from last, plus the second from last is, the second term is a plus d, and the last term is, which is our first, is a. So now from here we are going to add everything, the second and the first and the second equation. You're going to add them together. So we have Sn plus Sn, which is 2Sn is equal to, so if we say a plus the first term plus the last term, is going to give us a plus 10, which is 2a plus n minus 1 d, then plus we have a plus d plus a plus, so a plus a, which gives us 2a, then plus we have n minus 2d plus d. So since we are going to have negative 2d and positive d, so 1d, we are going to subtract 2d minus d, which is going to give us simply n minus 1 d, then plus it carries on, then plus. So this one is now if we do also solve for the third term and the third from last, it's going to give us the same solution. Now, so we go now to the last part here, which is the second from last plus the second term. So the second from last and the second term, this one which we are from doing here, which is giving us this answer here. Then if we do so for the first last term and the first term, we're going to have a plus which is 2a plus this part we don't have here, so we are going to just get this whole part which is n minus 1 d. So as you can see, these are repeating each other, they are repeating, so we are going to say 2sn is equal to, so out of this we're just going to get 1 because they are repeating each other, which is 2a plus n minus 1 d. So as you can see, these are repeating each other, so we don't know how many they are. There are a lot because of these dots, so it means there are a lot. So these you're going to present them by what? By the letter n, because you don't know how many they are. So you can divide throughout by 2, even if you divide by 2. So Sn will be equal to n divided by 2. Then you are going to have 2a plus n minus 1 d. So this is the formula that we use if the nth term is not known. If the last term is not known, we use this formula. But if the last term is known, we go back to this formula which is here on top. If the last term is known, but if the first term is not, the last term is not known, we use this term. If you are given to find the sum of the first n terms, we use this formula. But if you have been given the last term, we use this formula. So now we can move on to question 3 now. So for the tutorial sheet states, find the sum of odd numbers between hundreds and 200. So we're looking for the sum of odd numbers between hundreds and 200. So when you're answering such kind of questions, you have to ask yourself first, this question is one a odd number, or what are odd numbers? So odd numbers are numbers that's when you divisible by 2 to give you a remainder of 0.5. So whenever you divide any number with 2, if it gives you a remainder 0.5, it means that it's an odd number, or a number that cannot be divided by 2 and gives you a proper number. It will give you a number in decimal points, so that's an odd number. So we have numbers between 100 and 200. So we know that 100 is not an odd number because 100 can be divisible by 2. So 100 and 200, these are divisible by 2. So these are just starting points and ending points. So we are looking for numbers in between. So 100 and 200 are not part of the equation. So for these two, ask yourself, which one is the odd number? So from 100, the next number is 101. So 101, can 2 go into 101? No, it will leave a remainder of 0.5. So the first number is 101. Then the third is 103, 104, 10. So let's write this. So for number 3. So the first, our A will be 101 plus our B will be, our second term will be 103 plus 105. So this will go on over and over again plus from the last part we are going to have 197, let's say 195 plus we're going to have 197 plus 199. So these are the odd numbers. So from the first 3 and the last 3. So now let's look at what is our first term. So our first term is 101. What is the common difference? The common difference is 2, because if we subtract these 2, it is going to give us 2. Then our d is equal to 2. Then what is our last term? Our last term is equal to 199. So you ask yourself a question, between those two formulas which we had discovered from the first and second question, which one are we going to use? So we have two formulas here. So we have this formula which is here, which is Sn is equal to n over 2 a plus an, or we also have this formula which is s of 1 is equal to n over 2, where multiplied by 2a plus n minus 1 d. So you ask yourself, which among these two, which one are we going to use? So you have to identify what you have been given and what you have not been given. So from this question, you have been given to say we have the first term, the common difference, and the last term. So for this one, we don't know we don't have the last term in this formula. So we're going to use this formula because we have the first term, which is a, and the last term, which is a n. So we have our last term, which is a n. So now the question is, since we are using this formula, which is Sn is equal to n over 2, where we have a plus a n. So you have to ask yourself now, what is n? What is the number of terms in this AP? So we don't have our n from where. So again, if you write the number, you have to write the numbers, then you start counting them physically. Now that will just waste your time. So you can solve that the number. We can find n in just in just 30 seconds. So for an AP, the nth term of an AP is given by a n is equal to what? A plus n minus 1 d, where we have our a n, which is what? 199 is equal to what is our a? Our a is 101 plus n we don't have, so we have n minus 1. What is our d? 2. So we're going to have 199 is equal to, so 101 plus, if we might multiply by 2 here, we're going to have 2n minus 2. So 101 minus 2 gives us what? 99. So we have 199 is equal to 99 plus 2n. So 99 minus 2n. So we're going to have 199 minus 99 is equal to 2n. So if we subtract this, what are we going to get? We're going to have 2n is equal to what? Here we're going to have 100. So if we divide by 2, our n will be equal to what? 100 here. So n is 100. Oh, sorry for that. If we divide by 2, our n will be 50. Sorry for that. Yeah. So n is 50, not 100. So now we go back to this question. So when you go back here to this formula, now we have n to be 50, and you have first term and second term. So you're going to say s of n. So s of 50 is equal to 50 divided by 2, where what is our a is 101 plus an is 199. So if you add, so this gives us 25. If you add 101 plus 199 gives 300. So we are going to have 25 multiplied by 300, which gives 7,500. So this is our sum of an AP, where the between the integers or odd numbers between 100 and 200. So the sum is 7,500. We now move to our question 4. So question 4 is saying, write down the first 5 terms of the geometric series of an is equal to 2n plus 1, 4. N is odd. Then 2n minus 1, 4. N is even. So for n is odd, so odd numbers is the previous question you are from answering. So odd numbers are numbers which leaves a remainder divisible by 2. Then for even numbers which are divisible by 2. So let's look at the first part, which is an is equal to 2n plus 1. So is equal to, so odd number. So the first odd number is 1. So 2 times 1 gives us what? 2 plus 1, 3. Then plus, from here after 1 is 2. Oh, sorry, 3. So 2 times 3 gives us 6 plus 1, 7. Then plus, we go to 5. 2 times 5 gives us 10 plus 1, 11. Then plus, after 5 is 7. 2 times 7, 14 plus 1. So sorry, we have used 1 3, 5. So after 5 is 7. So 2 times 7, 14 plus 1, 15. Then plus it's continuous. So we have answered 1, 2, 3, 4. So then from here we have after 7 is 9. So 2 times 9 gives us what? 2 times 9 gives us 18 plus 1, 19. So we have 19 here. Then plus it carries on. Then let's go to the down part of this function here. So the down part is an is equal to 2n minus 1. So for n is even, so even number is divisible by 2. So we go to 2 here. So the first part is number is 2. So 2 times 2 gives us what? 4 minus 1, 3 plus. We go to now what? 4. 2 times 4, 8. 8 minus 1, 7 plus. We go to 6. 2 times 6, 12. 12 minus 1, 11 plus. 2 times 8, 16 minus 1, 17 plus. We go now to 10. 2 times 10, 20 minus 1, 19. So this number carries on. Oh, sorry. So here I said, from here I said 2 times 8, 16 minus 1, so it is 15 or 17. Sorry for that. So as you can see now from these two that giving, all of them are giving the same answer. So which means this equation is a function. So this proves that this equation is a function. So as you can see, we have found the first 5 terms, which is 3, 7, 11, 15, and 19. Alright, now let's move on to question 5. So our question 5 is find the sum of a arithmetic series with first term a. So the first term is 1, so our a is equal to 1, and common difference is 3, so our g is equal to 3, and the last term is 100, so our an is equal to 100. So this is our question 5. So since we have been given the last term, so we're going to use the formula for which the nth term is known, which is the last term is known. So for this one, we're going to use s of n is equal to n over 2, then a plus a n. So from here we have our a, which is 1, and we have our an, which is 100, but we don't have n, so we have to find n, the number of terms. So how do we find? So the nth term of an AP is given by an is equal to a plus n minus 1 d. So what is our an? Our an is 100, which is equal to our a is 1 plus n minus 1. Then what's our d? 3. So this will be 100 is equal to 1 plus. This will be 3n minus 3. Then 1 minus 3 gives us 2. So we're going to have 100. So this will give us negative 2. So plus 2 is equal to what? 3n. So 102 is equal to 3n. So if you divide by 3, you divide by 3. So our n will be equal to, so 102 divided by 3 gives 34. So our n is 34. So we now replace in this, go back to this form and replace. So sum of 34 is equal to 34 divided by 2, where our a is 1 plus our an is 100. So this gives us 2 into 34 gives 17 times this is 101. So this gives, so sum of the 34 terms gives 17. So just minutes. 1717. So this is our sum here. So now let's quickly move on to our question 6. Reads, show that the sum of the first n terms of the series 1 plus 3 plus 5 plus and so on is given by the formula Sn is equal to n squared. So we have the first term, second term, and the third term. So for this series, we don't have the last term. So we're going to use the formula for which the nth term is not known. So the last term is not known. So since we're talking about sum, so we're going to use since this is essential, we're talking about sum, so we're going to use the formula for sum. So Sn is equal to, so for which the last term is not known, so we have n over 2, where we have 2a plus n minus 1 d. So what is our n? We don't know our n, so it will be n divided by 2. So from here we can say that our first term a is equal to 1. Then our difference is 3 minus 1, which gives us 2. So we have 2 there 1 plus n minus 1, and our d is 2. So which we have n over 2, which gives, so 2 times 1, this is 2, plus 2 times z, this is 2n minus 2. So from here we have 2 and 2 minus 2, which gives us a 0. So we're going to have n over 2 multiplied by 2n. Now you have 2n, you have 2 here and you have 2 here. So these 2 and these 2, they can cancel. So you're going to have s of Sn is equal to n times n, which gives n squared. As simple as that. You prove this that the sum of this series is Sn is equal to n squared. So you have proven this one is the same one you have found here. So it means you have proven, as simple as that. Right, so let's move on to question 7. So question 7 is saying evaluate the sum of 2k plus 1 for the values of k in between 2 and 50. So for this question, what we're going to do is that we're going to, what there is k in this equation here, will be pressing 2 to find the terms of the number of terms of the GP. So this is an AP. So for this AP, we're going to find the first term up to the last term. So the first term, for the first term, k is equal to 2. Then for the last term, k is equal to 50. So I'm just going to get this equation and we'll be replacing 2. So we have, so 2k plus 1. So our first term will be, so we have s of n is equal to, so our first term will be, so when you press 2 here, 2 times 2, 4, plus 1, 5, then plus, after 2, the next number is 3. 2 times 3, 6, plus 1, which will be 7, plus, after 2, this is, after 3, 4. So 2 times 4, 8, plus 1, 9. Then so we're going to have plus C, 11, because we know the difference is just 2 in between these numbers. Then plus, it goes on and on. So now we go to the last 3 numbers. So for the last 3 numbers, so that number is 50, 49, 48. So let's go to 48. So we have k is equal to 48. So for k is equal to 48, 2 times 48, this gives what, gives us 96. So 96 plus 1 is 97, plus k is equal to 49. So 2 times 49 gives us 98, plus 1, 99. Then you have 50. So 2 times 50, 100, plus 1 should be 101. So from this, now we have this, a sum of this AP. So we know that our first term is what? 5. Our common difference is 2. And our last term, which is AN, is equal to 101. So since we have the first term and the last term, then you're going to use the formula s of n is equal to n over 2. Then where we have a plus a n. So in this equation here, we have our a, which is 5, and our an, which is 101, but we don't have n, so we have to look for n. So for an AP, the nth term of an AP is equal to an is equal to a plus n minus 1 d. So what is our an, which is 101, is equal to a is 5 plus n minus 1. What is our d? 2. So we have 101 is equal to, so we have 5 plus 2n minus 2. So this gives us 3. So we are going to have 101 minus 3 is equal to 2n. So 101 minus 3 gives us what? Should be 98. So we have 2n is equal to 98. So divide by 2, divide by 2. So our n will be 49, if I'm not mistaken. Yeah, 49. And then you will find that our n is 49. So we'll go back now here. So we're going to replace. So s of 49 is equal to 49 over 2. Then you have, what is our a? 5. Plus, what is our an? 101. So 5 plus 101, so which is 49 divided by 2. This is 106. So if we divide by 2, we're going to have 49. This will be 53. So we have 49 multiplied by 53. So you just have to punch on your calculator. So 49 times 53 gives us 2597. So the sum of the first of these 49 terms here in this summation here gives us the 2597. So this is the sum of this AP. So our question 8 is saying find the 15th term of a geometric progression whose 80th term is equal to 192. So our TH is equal to 192, and the common ratio R is equal to 2. Then we have been told to find the 15th term, so it's term 15. So we know that for a GP, the formula is given by Tn is equal to AR to the power n minus 1. So we have been given T of 8 is equal to A. We don't have our first term, then our ratio is what? 2 to the power n. So our n is 8 minus 1. Then you have A 2 to the power 6. So 8 minus 1 gives 7 is equal to what? 192, because T8 is equal to 192. So we have 192. So 2 to the power 7. So you punch in the calculator, 2 to the power 7, which is A 128 is equal to 192. So it divides by 128, even here it divides by 128. So our A is equal to, so 192 divided by 128. So our A is equal to 1.5. So the value of our A is 1.5. Now let's move on to find the 15th term. So I've been given to find our T15. So we input the formula for an AP or GP. So Tn is equal to AR to the power n minus 1. So we're looking for term 15. So T15 is equal to, what is our A? Our A is 1.5. What is our R? Our R is 2. Then to the power n. N is 15 minus 1. So it should be 1.5 to the power. So 15 minus 1 gives 14. So we say 2 to the power 14 times 1.5. So which gives T15. So our T15 is equal to 24,576. So this is our 15th term, which is 24,576. Alright, so now let's move on to question 10. So our question 10 is saying a film produced 20,000 DVD players in the first year, 2001. If production increases every year by 10%, what will be the production in 2009? So first and foremost, let's identify what do we have. Is this an AP, a GP, or an interest? So for this one, if you are using between AP and GP, you are going to use simple, or we're going to use GP. But if you are going to consider interest, then you're going to use compound interest. So let's answer it in terms of AP and GP. So in terms of AP and GP, so we're going to say, so this is our number 10. So we're going to say our A is equal to what? 20,000. Then what is our R? So our R is 1 plus 10% divided by 100%. So it will be 1 plus 0.1, which gives 1.1. Then what is our n? So our n is given by, so what is the last year? The last year is 2009. Then the first year is 2001. So the difference here is 8. So our n is given by 8. Then now let's apply the sum of a GP form, also in the nth term of a GP. So Tn is equal to AR to the power n minus 1. So now we're going to use this formula. Tn is equal to AR to the power n minus 1. So what is our A? Our A is 20,000. So Tn is equal to 20,000. Then what is our R? Our R is given by 1.1, which is here. So we have 1.1 to the power n. So what is our n? So our n is 209 minus 201, which gives 8. So between this, it is giving us 8, but since our 8 is not our n, so we're going to say 8 plus 1, which will give us 9. So our n is given by 9, because we are moving from 201 to 09, so to 209, so to give us 8. So we're going to add plus 1, which will give us a 9. So our n is 9 minus 1. So it is 20,000 multiplied by 1.1 to the power 8. So you just punch it all of this on the calculator. So 20,000 then times 1.1 to the power 8. So which gives 42,871.7762. So from here you can just round it off to be 42,871.78. So this is our T of 9. So in 2009, the production will be 42,871.78. So if you want, you can just round it off up to here. If you eliminate these two numbers, there's no problem. So if using these same numbers, you can also use now the formula for compound interest to solve this entire question. So if you can try it, you can try out on your own to using the formula for compound interest to solve this question. But our main interest was just using AP and GP, because we're answering questions on AP and GP. So our main interest is answering using AP and GP only. So now let's move on to question 11. So 11 is saying compute the sum of integers from 1 to 100. So we have from 1 to 100. So sum of integers. So integers are positive and negative numbers. So in this case, we only have positive numbers because we have been given from 1 to 100. So they are all positive. So from here, we know that our first term A is equal to what? 1. Then that term A is equal to 100. Then what's the common difference? So the difference is given by 1, because from 1 to 100 the difference is just 1 1 1 1. Then so from here we can say, to say that how many numbers are from 1 to 100? There are 100 of them, so n is equal to 100. So now let's solve this. Let's solve using the sum of an AP for which the last term is known. So Sn is equal to n over 2 a plus a n. So sum of 100 is equal to 100 divided by 2. Then what's our first term? 1 plus 101. So which is 50. Then this is 1 plus 101. So this is 50. So this is 100. So 1 plus 100 gives 101. So 50 times 101, which gives 5050. So this is our answer here. So the sum of the integers from 1 to 100 gives 5050. Right, so now let's move on to question 12. So question 12 we said, what is the smallest number of terms of the geometric progression 2 plus 6 plus 18 plus 54 plus 162 plus continuous? Then that will give a total greater than 1000. So a total greater than, so it means the sum of this geometric progression should be greater than 1000. So the sum should be greater than 1000. So now let's interpret the data from here. So what's our first term? So our a is equal to 2. So since this is a geometric progression, then our r is given by, so T2 over T1. So what is our T2? 6 divided by 2, which is equal to 3. So let's prove. So 2 times 3 gives 6. 6 times 3 gives 18. 18 multiplied by 3 gives 54. So 54 again gives 162. So which is correct. So our is equal to 3. So now let's input the sum, the formula for the sum. So S of n is equal to a, then you have r to the power n minus 1 over r minus 1. So we have started with r to the power n simply because our r is greater than 3. So the ratio we have found is greater than 3. So that's why we're starting with a, r to the power n minus 1. Then, so let's now start replacing. So Sn is equal to, what is our a? A is 2. Then you have r to the power n. So r is 3 to the power n, you don't have minus 1 over r minus 1, which is 3 minus 1. So remember that Sn, so Sn should be what? Greater than 1000. So we're going to say 2, then you have 3 to the power n minus 1 over, so 3 minus 1 gives a 2, then it should be greater than 1000 here. So these 2 and these 2, they can cancel. So we're going to remain with 3n minus 1 should be greater than 1000. So 3n should be greater than, so this one can close, so it should be 1000 plus 1. So 3n to the power n should be greater than 1001. So then from here we can now introduce log. So we're going to say n in 3 should be greater than in 1001. So divide by in 3, divide by in 3. So our n should be greater than, so we say in 1001 divided by in 3. So this gives 6.2886190607. So if we n, so for n, if we say that n is 6 point what to give us exactly 1000, to give us exactly 1000 here. So this is just an estimation. So n, if we say this value we have found is going to give us the exact value here. Now since we're trying the number of years, you can say put them in points. So you see that n is equal to what? 6 or n is equal to 7. So how can you solve which one is correct and which one is wrong? So you have to choose the correct one and the wrong one. So 6, so you have to say 6, you have to compare 6 and this value. So 6 and this value, so this value is giving us exactly 1000. So it means if we use 6 will give us less than 1000. So what number is greater than 6? Which is 7. So therefore our n is equal to 7. So this is the answer which is going to give us the sum which will exceed 1000. So n is equal to 7. So now let's move on to question 13. So question 13 is saying rewrite 0.14 as a series and find its sum to infinity. So as you can see, 14 as a bar. So this means to say that this 14 is repeating itself. So therefore, this is an irrational number because after the points, the numbers there are repeating each other. So let's write it as a series. So the first series will be 0.14. Then the second one will be 0.14 multiplied by 100, which is going to give us 0.0014. So we are going to say the second term divided by 100. So 0.14 divided by 100, which is 0.0014. Then to find the third term, we are going to say the second term, which is 0.0014 divided by 100. So if this value, if we divide by 100, it's going to give us 0.000014 plus. Again, this one we're going to divide by 100 again, which is give us 0.000001. So again 0014 plus. So these numbers they'll still go on because the 14 that still they'll be repeating us throughout. So we can end here. So from here we know that our first term A is 0.14. Then let's find our common ratio. So our common ratio R is equal to T2 over T1, which is equal to, what is our T2? 0.0014 over 0.14. So let's find the ratio there. 0.0014 divided by 0.14. So our common ratio is 0.01. So we have written it as a series. Now the question is saying now find its sum to infinity. So for sum to infinity is given by A over 1 minus R, provided R is where R should be less than 1. So what is our A? So we move on here. So our A is 0.14. So we say 0.14 over 1 minus 0.01. So 1 minus 0.01 will give us 0.14 over 1 minus 0.01 gives 0.99. So from here, what are we going to do? Since we are going to multiply by hundreds, so since there are both of them have two decimal places after the point, so we're going to say multiplied by hundreds, even here multiplied by hundreds. So we're going to have 14 over 99. So if we divide 14 over 99, it's going to give us 0.14141414, which proves our question. So for this one, the sum to infinity of this GP is 14 over 99.